pocket or tool belt. Continuous and discrete are two words you haven't seen probably until now in association with a graph.
Please excuse the interruption. Sorry for any confusion. Today is a Wednesday, not a Tuesday, so that means there is no student store today. It was done yesterday for grades 1, 2, and 4. Tomorrow will be grades 3 and 5. Again, sorry for the confusion.
Some graphs that represent real-world situations are drawn without any interruptions. In other words, they are continuous graphs. You are used to seeing a continuous graph. This is not going to be new to you. It's a graph that is made up of a continuous line. All the linear equation stuff that we've done in 8th grade that you did last year is a continuous graph. This is the normal graph that you are used to. It has a connected line. So it might look something like this. There's your X, there's your Y axis, here's your X axis, and a continuous graph will look like that. It is a straight line, or a curved line. It's just a line that goes from one end to the other. Here's your new type of graph that may not be as familiar. A discrete graph is made up of distinct or unconnected dots. Tony. Discrete in English, yeah, I don't know. I have no idea the language behind math. If you're into language and want to look up how they got that into the math textbook, Google is your friend. My wife was a English major though, so she might know. I'll check in with her. Example. Make a mini coordinate grid like this, and here's your discrete graph. They are parts that are unconnected points. You do not draw a line. Normally you would because you're graphing something, but when it's discrete, you do not draw the line. It is only these points that make up the graph. The domain is a new word. Domain of the graph is all of the values that x are shown on the graph. The range is all the y values that are shown on the graph. Domain is x. I'm looking down on the graph. Domain, I think down. It is all the x values that could possibly happen. The range is all the y values. I'm looking up for the range. Let's take a look at a real-world example. A student's taking a test. There are 10 problems on the test. For each problem the student answers correctly, the student receives 10 points. What type of graph is this? Turn and talk to your partner. 5 seconds. Go. Write it on the line. There is no line connecting it. It is discrete. The domain for this thing is all of the x values that it could be. So the domain for this could be between 0 or it could be up to 10. The domain is all of the x values it could be. This is 0, this is 1, this is x is 2, x is 3, x is 4. Could you score over 100 points and get 11 questions correct on the test? The domain cannot be 11. The domain cannot be -1. The domain has to be between 0 and 10 because these are all the questions. In algebra, you're going to write it like this. They already wrote it for you, but I want you to write it on the line. They put a P here for points or problems, actually. You could put a P or an X. So the problems have to be more than or equal to 0. You either finished 0 problems or more, and it has to be less than or equal to 10. You either finished all 10 or less than 10. That is your domain. The range is all of the points on the y value. So you can go between 0 points to 100. You can't get more. Your range would be written like this. 0. It has to be bigger than 0. You're not going to score less than 0 on a test. But it has to be less than 100. No extra credit points offered. In algebra, this is how it's written. Cool. Domain, range, new vocab words that you will need in your algebra lives. Example 2, a bathtub is being filled with water. Actually, wait, go back up. Don't flip. I want you to think about this before we move on to a continuous graph. Why is this discrete? Mr. MacD sometimes gives you guys a test where I give you like partial credit or like half points, and you can score like 2.5 out of 5 for showing some work. This test only offers whole points. Could I score in between these dots? Is it possible to score, if this is 20, could I score a 25% out of 100? Elliot? I could not. Why not? It would have to be continuous in that sense, but this test only offers 10 questions with 10 points each. They do not offer a 5-point option. This is not continuous because it is limited to only 10-point chunks. You cannot draw a line to connect it. That is discrete. Example 2. Are there some other ones? I wanted to get into the apple example. Whatever. I'll get to that later. Read example 2 for me, please. Andrew, a bathtub. There's a lot of information. Let's take it a piece at a time. A bathtub is being filled with water. After 10 minutes, there are 75 quarts. At 0 minutes, how many quarts are in the bathtub? 0. It is empty. Start at 0. After 10 minutes, there are 75 quarts. Go up to 75. This is 15, 30, 45, 60, 75. Go over to 10, make a dot. After 5 minutes, are there a possible amount of water in the tub? Is there some water in the tub after 5 minutes? Sure, this is not a discrete graph. This has to be continuous. It doesn't just magically dump water in at 10 minutes. There has to be some in between. Although that would be pretty cool if you just like pulled a cord and just had the water. Just like magic. Someone invent that. I will buy your bathtub. Okay, so this is the 10 minutes. Then someone accidentally pulls the drain plug, which may or may not be my 6-year-old son, and the water is still running. The tub begins to empty. From this point, the tub loses 15 quarts in 5 minutes. From 10, go over to 15, it loses 15 quarts. So in 5 minutes, at 15 minutes, go down 15 quarts. It lost some. Someone plugs the drain for 6 more minutes from 15 over to 21, and it's going to gain 45 quarts. From 60 to 45 is 105. We'll have to estimate. If that's 90, that's 105. Oh, that is good. Right there's 105. Go over to 21. Make a dot and connect. After 15-minute bath, the person gets out and pulls the drain plug. It takes 11 minutes for the tub to drain. How do you show 15 minutes of a bath from 21 to 36? How would I show a 15-minute bath, Tanner? It does not fill up. It is straight. Beautiful. 15? So we were at like a funky, what, 21? Did I do that math right? It was at 15, 6 more minutes was at 21, and then it's going to be 36. Right about here. I probably put it over too much. And lastly, it takes 11 minutes for the tub to drain. What is that going to look like for it to drain? Order. It's emptying. 11 minutes from 36 is going to be over to 47. It's going to go right about there until it gets to 0. At any point, you could track how much water's in the tub. Even though they're not telling you the specific time happened at the event, you could go over to 33, you could go over to 27, and find the amount of water in the tub. This is continuous. The domain is all of the x values that could possibly happen. So the domain was in time. You could have 0 minutes and track that, or go all the way up to 31 plus 11? No, 36 plus 11. 47. So it could also be at least 47 minutes. So your domain has to be bigger than 0 or less than 47. It could be equal to those as well. Anywhere between 0 and 47. What is the range? Turn and talk to your partner, then try to write it algebraically with them. Go. 0 to what? Where did we even get to? I have to add up the 75 minus 15 is 60 plus 40, 66. 3, 2, 1. You might have had to go back and do the math. It's kind of hard to see. It started at 0. Where was the peak of our tub age? Elliot? It was 105? Was it 106 though? It got up to 105? Okay. I thought it ended at like a funky number. My graph's a bit off then. That's fine. So your range is all the y values it could be. It can't be more than 105. It has to be more than 0. That's the range. Domain is down here. Try these two. Sketchagraph the situation, tell if it's continuous or discrete, and determine domain and range. When you're determining it, write it algebraically and get in the habit of writing that x in the middle of the two terms, or the two ranges and domains. I'll give you 3 minutes. If you need more, I'll add a minute or 2. Once you finish the first graph and domain and range, check with your partner that it looks similar. Then go to 2.
Double shot. Finally
Got it.
hold down the ball button for 2 seconds to select the game, or just shoot.
A few of us are done. Before moving on to bronze, check out your continuous graph, compare it with the students. Kieran, what is happening in the first 2 hours? It's increasing 2 inches an hour. So it went up here to 2. A few of us I saw put a little dot at 2 just to make it easier to connect. And then it went up again at 4 inches. So after 2 hours, there are 4 inches on the ground, which may be true at my house tonight. It's supposed to snow 5 inches. Hooray. Then it slowed to 1 inch an hour. That is the gradual slope here. That's 1 inch for 1 hour. It stopped 3 hours. Is this length of time? It stays the same and then it begins to melt. Why doesn't it go back to 0? A few of us connected the line all the way down here and ended at 0. Why isn't that true in this scenario? Why doesn't it go all the way here, Tony?
Because it doesn't tell us how many hours it melts for.
Yeah, it just says in the scenario it's melting for 2 hours. It's possible it continued to melt, but they just told me it melts a half an inch for 2 hours. So after 2 hours, a half an inch times 2 would be 1 whole inch. That's the 1 inch that it melts, and it stops at 4 inches on the ground. If you have to change that, go ahead and fix it. Kieran, you might want to change the details of how big your line is. Like you made like a miniature version of this. Yeah. What is the domain for this? Explain it to me. You can look at the answer on the board too. Tony? Is it 8?
Yeah, because it says the 2 hours. It is 8.
3 hours, we end melt for 2 hours. Two hours, 1 hour, 3 hours, plus 4, plus 3 is 6, and then 2 is 8. Interesting. Weird. Why don't they label that? Okay. Make sure you add it up in the actual scenario because it should be 8. It says 7 though. It has to be between 0 and 8, and the range has to be between 0 and 5. Why is the line underneath the inequality? When you're doing ranges, it will almost always have the line underneath. Why does that make sense, Tony?
Because that number is in the graph.
Mm-hmm.
There's a point on it.
It's a part of it. and the point is on that one, so it needs to include it. The line under means equal to or less than. Equal to or greater than. A salesman's going door to door to sell vacuums. He makes 20 bucks. What type of graph is this? Continuous or discrete? Kylie. It should be discrete because you cannot sell half of a vacuum. If you get a scenario, just kind of use the half test. If you can buy half a vacuum, they'll tell you. Otherwise, just assume you cannot. So after he sells one vacuum, he makes 20 bucks. 2 vacuums, he makes 40. 3, he makes 60, all the way up to 10 vacuums. Your domain for this, what does it look like, Porter? Look down at the numbers. What is the domain down here?
Testing, testing.
Good. What's the range for this one, Kieran?
0 is less than or equal to x, and 200.
All the way up to 200. Great. Number 3, I want you to think about, it says how you can tell when to use discrete as opposed to continuous. Give an example of each. Think about when it would be possible to graph something that is continuous versus discrete, and give me an example. You might want to think about going to the store. An example I always go to is if I go to the store and my daughter loves bananas, but she only eats half a banana. And so every time I go to the banana aisle, she like wants to rip off the banana and then like take a bite and then be done with it. And I'm like, that's not how it works. You cannot buy half of a banana at the checkout station. You would have to buy per banana the weight that it actually is. What movie is that? It sounds really familiar, but I can't think of it. Yeah. So when you're thinking discrete, I think more like shopping, or you could think of selling some things. You usually don't sell half of it. Continuous, you're thinking of something that can be tracked every single second. A lot of the time I think of like something that happens over time. You could track the score of a basketball game from 0 to 40 minutes. Do you guys have 10-minute quarters? 7-minute quarters? So that'd be 7, 14, 28 minutes in the game? That's it? Oh yeah, right. I just thought it was longer for some reason. High school is longer. I got it. Okay. So give an example. Check in with your partner. When you have an example, then go to bronze. Anyone have any creative examples for continuous? Yeah. Is that an example, or is that how you can tell? That's like how you can tell. What's a real life example? Something gradually rising could be these, or declining. That could kind of go with the rainfall. Usually storms come in like gently at first, like the last few storms. My son was super into watching the bomb cyclone circle in the ocean, and you can like see the bomb cyclone going into the land and like getting San Francisco first, and then you'd see like the sprinkles of rain in the foothills and Grass Valley and Nevada City, Elliott stop. And then you'd like see the actual bomb cyclone portion of it go closer into our area, and you get a lot more rainfall. So that would be a gentle slope that would look something like that. This. A little bit of rain, a lot of rain. That's continuous. You can track it any amount of time you want. Any discrete graph examples besides buying an apple or one banana? What about scoring points in a game? So you could look at like number of shots that you take. You can't score half a point. So number of shots in a game and the amount scored. You can't score half a point. So you could have one shot, you score 2 points. 2 shots, you score 4 points. Like that. That could be discrete. I like that one. Next page. Cool. 1 through 8 have 3 graphs for you to plot. At the end, with 5 minutes to go, I'm going to show you a scenario that my 7th graders in pre-algebra taking 8th grade math created with a video where you're having to watch them run across a field and you need to plot what is happening as they're running, if they're going faster or slower or staying the same pace. It'll be fun. Do you guys have room on the back of yours? Oh, you know what? This was the weird one where your answers were off, I think. Yeah. You don't have answers for actual graphs for 1 through 7. Sorry. Yeah. 1 through 7 is happening in 10 minutes. In 7 minutes, then I'll pause to do the video. Crack